In today's lecture, we are going to learn big O notation analysis. So for what reason we are going to learn big O notation? For get to know that how we can calculate the time complexity of any algorithm and what is the meaning of upper bound. So suppose if I'm making one graph like this and this, if a function after a particular time, that is n naught, is always less than that, then we can say this is the upper bound. We can say this is the upper bound. So we can say that Fn is big O Gn if and only if Fn is less than or equal to Cgn, where C is between these two, the gap. What is the gap? And C is a constant. So we can say that there exist two positive constant C and n naught. C and n naught, where n naught is greater than 0 and C is greater than 0 for all n greater than or equal to n naught. So what is that? I just explain you with one example. I am taking one example because what we need to show that Fn is always less than equal to Cgn, and we need to put some C value, and C is a constant here. And after that particular value, if it is starting from 0, suppose I am taking just value 10. After that 10 value of n naught, this function is always less than the Gn. Before that it can be up, it can be down, it can be anything, but before that n naught value it is always less than the Gn. Then we can say it holds the condition for big O notation. So suppose I am taking one example in which Fn is equal to n plus 10 and Gn is equal to n. So we need to prove it. So what is the relation? Relation is Fn is less than or equal to Cgn. So I am putting Fn value is n plus 10 and less than equal to Gn is n. So we need to find out what is C value here. What is C value here? So suppose because here n plus 10 or here it is n, so we are able to see that we can take n naught value as 10. Then only it can be equal from here. So suppose if I am taking n naught value as 10 and after that I am taking C value as 1. If I am taking C value as 1, then what will the result? I am just giving you trial and error so that you can understand how we can do that. So suppose if I am taking n naught as 10, so 10 plus 10 is less than equal to, if I am putting C value as 1, so it will be 10 only. So it cannot be equal because it is 20. So suppose if I am putting instead of 1, if I am putting n C value as 2, so it will be 2n. It will be 2n. So 2n will be 20. 2n will be 20, right? So 20 is less than or equal to 20, right? This is one n naught value. Now it should be satisfy all the condition after that n naught value. So suppose if I am taking n value as 11. I am taking n value as 11, right? Here I have taken 10. Now I am taking 11. So what its value will be? 11 plus 10, right? 11 plus 10. And here it will be 11. So 2 into 11. So what it will be? 21, and it will be 22, right? So it holds the condition 21 is less than 22. Suppose if I am taking n is equal to 12, right? So here it will be 12 plus 10, and here it will be 2 into 12. So what it will be? 22, and what it will be? 24. So you are able to see it holds the condition true always. So that is the meaning of that function. We need to find that the C and n naught value like this, that after that value it always holds true. It means Fn value is always less than the Gn. So we are able to see here if we are taking n naught value as 10 and C value as 2, so this condition always holds true, right? So this is one thing. Another thing I just want to say that in this function we have two things. Fn is less than equal to Cgn. So what is the meaning of that, right? So I'm just showing you here again with one example. Suppose if n square is equal to big O n square, So we can say this is because it is exactly equal to, this is also n square, this is also n square. So we can say this is the tightest upper bound. This is the tightest upper bound because value should be exactly equal. And again, if I am taking one more example, n square is equal to order of n cube. So here it will not be, I'm just writing again, n square will be small o n cube. This is big O, this is small o, small o. So here we are able to see this is not tightest because what is the condition? Fn is less than equal to Cgn. It is satisfying what condition? Fn is less than Cgn. Here and here what is satisfying? Fn is equal to Cgn. So if it is equal to, then we can say big O, and if it is less than, then we can say small o. So if any other example is like that, we can say n square is equal to order of n to the power 100. So this is small o. Small o. So this is the difference between big O and small o. In big O, it should be always equal to, and in a small o, the Fn condition can be less than the Gn. So this was all about the asymptotic notation big O for upper bound. So in the next video, I'm going to show you the omega notation analysis. If you like it, share it, subscribe it. Thank you.